Dr. Sarah Kitchen. I am a researcher at Michigan Tech Research Institute, and the name of my team is BARCS, which stands for Bayesian Adaptive Robotic Control System. We are really interested here in bringing together two kinds of research technologies. One is integrating new novel sensor and signal processing methods into robotics, and the other is bringing to bear novel multi-agent strategies, collaboration strategies. We're focusing on understanding or having the robot understand and process what is meant by interior space in the environments. And since we're able to detect and understand what the interior space and the environments are, then we're able to make representations of that interior space that they can use in their joint search strategies. Initially, they're interested in getting into the tunnel and exploring more or less as deeply into the tunnel as possible. And also at the same time, they're interested in spreading out from each other. So we do have strategies for identifying at branching points in the tunnels or intersections, sending them in different directions from each other. We are trying to use breadcrumbs. Yeah, we're still working on that. That's going to be an important part of getting the UAVs really to do their maximum amount of effective work, because the further we can send them into the tunnels and not, strictly speaking, have them come back, the better. Using our image processing, which tells them where there's danger, they will take that information and put it into their list of frontiers that they're exploring, and they're able to blacklist frontiers as too dangerous to explore. And that way, when they're sharing that information with each other. And so that way, if one robot has explored some area of the environment and has found something dangerous that they don't want to fall down, then they can share that information with other robots who haven't gone to that area, and so they'll get the same blacklist information. So they'll know that there's a frontier there, but they'll know it's a frontier that they can't explore. If a robot has gone down a tunnel and the tunnel is blocked behind him by a dynamic rockfall, then if he tries to traverse back along that path as like part of his global plan, then he will run into and he'll encounter basically a trajectory that it'll be a node in his plan that that he's no longer able to traverse. And so he'll try for a little while to figure out if he can traverse it, and then he will blacklist that node and he will have to replan globally. They carry the artifact information around with them the entire time they're exploring, and anytime they encounter another robot, they share that information with each other. And so any of them who gets back to the base will be transmitting all of the information from all of the robots they've encountered along the way. One of the things that we're really excited about doing in the next year going forward is getting the environments mixed together. And I think we have really exciting strategies for handling the extra challenges that come with transitioning between those environments during the runs. So, I mean, we've really enjoyed participating in this challenge so far, and we've participated in all of the circuits to this point. We're really excited about taking the technologies that we have developed for the tunnel circuit, urban circuit, and cave circuit and bringing them together for the final challenge.